to Session 7 of Complexity Explorer's Agent-Based Modeling in Python Mesa tutorial. In this session, we'll continue from our sugar and spice traders, our sugar and spice agents, and initialize our trader agents. So let's get started. Little forewarning, this one is somewhat monotonous, a little bit longer than the previous ones. So the first thing we want to do is make sure that you've uploaded your sugarmap.txt file. All right, here's the upload button. And then you import your dependencies. If you've done headers, you can then collapse that cell. Right? We then have our sugar agent class that we built that have a couple attributes: position, max sugar, and the amount of sugar that it has. Right? And then the same with spice. Then we have our trader agent, where we'll initialize this towards the end of the lesson. And then we have our model class, where we initiate our model, and this is our main manager of the agent interactions. All right, so in this we build our sugar and spice agents based off our grid allocations. All right, and if you run it, it should work, and you can see all your spice and sugar objects. All right, so now we can get rid of those print statements that kind of verify what we believe is happening in our simulation so far. And now we're going to create our trader agents. Right, so our traders have a lot of variables, and so it's going to take a little bit to kind of build all these variables in. And we're going to be somewhat verbose in building this, just to make sure it's very clear to all the people going through this. So the first thing is keyword argument, or kwarg. That's the initial population. And we're going to set this to the default of 200, which is a population size in our reference book, Growing Artificial Societies by Axtell and Epstein. Okay, then they have several parameters. So you have your first, the minimum endowment of sugar and spice, right, which are both between 25 and 50. Right, so we're going to create kwargs for that, endowment underscore min and endowment underscore max. Right, and then we have a metabolism for each agent for sugar, right, and spice. And again, these are going to have vary. So we have metabolism underscore min at 1, right, metabolism underscore max at 50. And again, we're defaulting these parameters to or correction, metabolism max at 5. We're defaulting these parameters to what was in growing artificial societies, right? Then we have the same for min and max, right? So we're doing these as keyword arguments, so they automatically set to something, all right? But they could later on be parameters that we alter to see what impacts it has on the functioning of our simulation. Okay, now that we've done that, right, we want to carry those variables over into attributes of the model, so potentially they could be referenced. Depending on how you set up your model, you don't necessarily have to do this set, but for us, we're going to do it so that way the model has attributes that could be referenced later for data collector and some other things. Right? Okay. And so really, again, somewhat monotonous. But we just do initial population equals our initial population, our initial endowment underscore min equals endowment underscore min, right? We want to make sure that we're always putting um, in our comments. I'm gonna do a little bit of cleanup here just to make sure everything follows the same structure. All right, but we initialize the width and height of Sugarscape, and now we're going to initiate uh, our uh, our population attributes. And so just to keep them, you keep everything the same, so you have consistent structure throughout. And for easier readability, we'll call this initiate population attributes. Okay, so now we have our initial population, our endowment min, right? And then we just want to make sure that it follows the same order, right? So population, endowment min, endowment max, metabolism min, metabolism max. And we just go through, all right, and we add each of these. Again, depending on how your model's set up, you might just want to pass in a parameter to initiate it. In this case, we're going to make each of our parameters an attribute of the model. So now, yeah, each of these parameters will actually be a range that we'll use later on, right? So that way we can have a heterogeneous population. One aspect of agent-based modeling is the heterogeneity of the population, which produces novel emergent behavior that a homogeneous population could not typically do on its own. And this becomes one of the key value added of agent-based models because it allows for kind of richer emergence and bottom-up simulations because each agent, because of the diversity of your agent population, right? And so each one of these, the min and max, all right, we'll use later on. So that way, as we initialize our 200 agents, they have variance in what their metabolism is, what their vision is, right? And then this has an impact on the overall output of the model. Right, so now just to make, we got a keyword arguments. Our keyword arguments match our model attributes, and for ease of readership, right, they're all in the exact same order, right? So it goes initial population, endowment, metabolism, vision, right? And then our attributes follow that same pattern: initial population, endowment, metabolism, vision. Well, this makes increases the readability. Okay, so now we've done our, we'll just add one more for loop. Okay, so we got our for loop for our sugar, our for loop for our spice, and now we're going to add our for loop for our initial population. We'll just do the standard Python convention of for I, right, in range, right, and then the parameter self underscore initial population. So that way later on, if we made it 50 or we made it 5 million, uh, uh, the the model would account for that without a lot of work on our end. So now the next thing we're going to have to do after this is then get each of those agent attributes, right, so that we can initialize each agent object, right? So we're going to initialize, in this case, 200 trader agents, all right, each with varying attributes, right? So first, we have to give them an x and y coordinate, right? So we have to put them in our 50 by 50 grid square. So we'll use uh, Python's random function, rand range, which returns an int. And remember, for Mesa convention, your x-axis is your width, right? So standard Cartesian coordinate system, all right? And the other bit, though, is we didn't actually import random. Random's part of the Mesa.model agent class, right? So typically you get an error saying that random is unknown, but because you're inheriting it from the Mesa.model class, that is why we're not importing it. So we do the same. So we do for x. Now we do the same for our height, which is our y-axis. Use rand range that returns an integer, right? Because if it returned a float, you would get an error from Mesa because you can't have a float grid coordinate. Okay? And now we have to add uh, each of the attributes for our agents, right? And if you want to see where we got this from, right, it's always good to document your kind of sources or provide references for your users. And in this case, we're basing all of this off Growing Artificial Societies, specifically page 108. So now the first thing we'll do it again, just like up above. We've initialized the population. You got your width and your height. All right, so now we'll follow that same pattern of endowment, metabolism, and vision. All right, again, this just kind of follows the principle of least surprise. If it's in one order in one place, you want to make sure it's in that same order in all the other places. All right, so first we'll need the initial endowment of sugar for each trader agent. Right? And per growing artificial societies, they use a uniform distribution. So again, we'll use Python's random uh, library. In this case, we'll use uniform. Right? And we'll do just your lower and upper ranges, which is your endowment min, which was 25, or defaulted to 25, and your endowment max, which was 50. We'll also then do int, right? Uh, just kind of to be consistent with what's implied in growing artificial societies. Right, then we do the same thing for spice, right? Int self.random.uniform, and then we use the attributes endowment underscore min and endowment underscore max. Now again, you could just pass these in as parameters and reference the parameters during the initiation phase of the model, but in this case we turn them into model attributes uh, that so they can be referenced later on. Okay, so again, we start with endowment. Next up is metabolism, and it's just going to follow the same process. Make sure we put in our comments, right? So first we give them the endowment, then we give them the metabolism. Each agent has a metabolism for sugar and a metabolism for spice as one of their attributes. And again, this determines how much sugar and spice that each agent will burn uh, every step of the model, right? Or tick of the model. So every time the model goes through one of its sequences, each agent will burn a certain amount of sugar and spice. And if they lose all their sugar and spice, then they are considered to have died and are removed from the model. I want to just make sure to check it. And again, well, kind of from the implication of growing artificial societies, we're going to turn these into ints. We have sugar, we just do the same thing for spice. And again, potentially on how you want to code it out, could say this violates the drive principle and turn all these into helper functions. In this case, we're just going to, again, as stated earlier, be a little bit more verbose, so it's more obvious specifically what's happening in the simulation. Right? And then next up is vision, right? So we have a position for our agent, we have a sugar, amount of sugar and spice endowment, they have amount of sugar and spice they burn between 1 and 5. Um, and now we're going to do the same for vision, right? All the same process. Right? So now as it iterates through this for loop, right, for each one, uh, each of these variables, sugar, spice, vision, metabolism, sugar, will all get one integer, and then we will assign that to our trader object. Then we got a process for getting each specific attribute of the agent. We can instantiate each trader object. So similar to sugar and spice, we make a variable trader, call our trader class, that's the capital T, and then we'll have to pass in the kind of standard attributes. So first, right, is always your unique ID, right? Every agent must have a unique ID just for the standard bookkeeping practices. Well, then you got your model, and then we'll go through the same process, right? Position, sugar endowment, spice endowment, sugar, metabolism, spice, and vision. And just instantiate each agent attribute with that. Correct this. It should be unique ID comma self, right? And then that will reference the model class that we're in right now, right? Model would, if we put model there, that would have given us an error, right? So next up is position. So we make a tuple of our x and y that was randomly assigned, right? And then we're gonna again be a little bit more verbose. We actually have to put in whether or not they're using the Moore or von Neumann neighborhood, or rather, we're gonna put it in so you understand that that's an attribute of Mesa. Right? So you have Moore equals false. That means they're using just up, down. Then we're going to use keyword arguments. This is just to make sure that as you're going through this tutorial, you get the exact right parameters where when you pass it up to the trader, and this will reduce the chance for error. Again, we're being a little bit more verbose here, but we're doing that intentionally to hopefully prevent you from getting unexpected errors. Right, so it goes more sugar, spice, then metabolism underscore sugar. And that's going to equal your metabolism underscore sugar, right? So it's just passing um, one variable into a parameter of the same name. And again, principle of least surprise. If it follows one pattern in one place, you want to make sure it follows that same pattern as you in another place, right? So it will go sugar, spice, metabolism, sugar, metabolism, spice, and then fission. Right? And again, this is just to make sure we don't accidentally or reduce a chance for incorporating error. Right, so now that we've created our trader object, we need to do the same things that we did with our sugar and spice objects. All right, sorry, should be agent underscore ID, not unique ID. Should probably go back through and correct this. Make sure you don't have any spelling mistakes like I do or other issues. All right. But now that we've created our trader object, just like our sugar and spice object, we want to make sure that we add them to the schedule and place them on the grid. Right, so again, always add comments, so place agent. So self.grid, place underscore agent, right? Then you pass in your object and you pass in their X and Y position. You could also write this as trader.pass, right? And then it will pass in that specific attribute of the agent. Right? Then we'll add it to the schedule. Right? And then finally, we want to make sure we iterate our agent underscore ID. Otherwise, we'll just be overwriting the same agent. So let's say it's 4032. I'll have is a agent 4032 recreated 200 times. All right, then always code a little, test a little. So we're going to put a print statement in here to make sure that they each have a unique ID. They're each on a unique position. They have some amount of sugar, right? And they have some type of metabolism. Since we use effectively the same code for the metabolism as we did for the vision, we'll just leave it at one. Right? So do metabolism spice. Okay. So now we got this for loop. We instantiate our agent, then we add them into our model. Make sure that we iterate through. Now we need to make sure that, well, if we run this, just to show you, we'll get an error. Whoops, and it looks like our name error, trader is not defined, so we never ran this cell. So first we got to run this cell. And now, right, since the number of parameters in there, if we run this, right, we look at our trace back, right, we see that we get an unexpected keyword argument more, and that's because when we initiate the trader class, it doesn't have any of the parameters that we put in. Right, so again, this just follows the same pattern, unique underscore ID, get an agent ID, model, right, which is the self in the previous one, their position, uh, their more, and again, we'll use keyword arguments here, just so it defaults out. Right. So again, more is a type of neighborhood, and von Neumann, since it's false, more is up, down, left, right diagonals. Von Neumann is top, bottom, left, right, which is what was done in growing artificial societies. And then we're going to put, we'll just put these out as 0. So that way, if something doesn't get passed through like we should think it should create a pretty obvious issue. And again, we follow the same pattern. More, sugar, spice, metabolism, sugar, metabolism, spice, and then vision. So again, it's very verbose for this, but hopefully this should prevent you from having any errors or issues when you actually run your code. So now, just like the sugar and spice agents, first we're going to do a super init. So that way you can just inherit the unique ID and model from our agent class. And then we just go through the same laundry list of attributes. So first you have your position. Then we have how they're looking at their neighbor. Right, so this is an agent attribute to say how they're looking at their neighbors, which grids they look at. Right, then the amount of sugar that they have, the amount of spice that they have, kicked off with an initial endowment. Then how quickly or how much sugar they burn in each step. Then how much spice they burn at each step. Right? So if they're burning a lot of spice, their chances for survival are less because they might run out of spice and not be able to continue on. Let's say, unless they randomly end up on a very rich spice hill. Right? And then their vision, right? So if they have a low vision of 1, they can't see very far. If they have a high vision of 5, that they can see further. Again, that might increase their chances of survival because they can optimize which path they're taking more effectively. And again, it just follows all the same pattern. And we've instantiated our trader agents. Right? So now when we run it, okay, look at that. We can see that each one's got a unique ID. They got a position. So now we can actually see if our keyword arguments are working the way we thought. So if I comment out one of these attributes, instead of getting an error, do metabolism spice, since we print that out, you can see it all just defaults to 0. Okay, so uncomment that out. Another interesting thing to be aware of, right, our unique subtlety, if you look at these, we're seeing at most 4 when our max is 5. And the reason for that is because when we do int, it doesn't round, it just truncates, right? So we get, some float number between 1 and 5, right? But it'll be like 4.9, right? And then that'll just be truncated to 4, right? So in order to be consistent with growing artificial societies, we want to make sure that we account for the fact that agents can, in fact, have uh, a vision of 5, an endowment of 25, or even a metabolism of 5. So it's a pretty easy fix. We just add a +1 to each of these. And so now we brought that, run our instantiate our model again. As you can see, now we get some 5s and some 4s in there, some 2s and some 3s. So that way, when it truncates, if we have 5.1, it'll truncate to 5. So It's just an important point to understand, particularly Python primitives, what they actually do instead of maybe assuming that they're rounding. Okay, in this case, right? So in this case, in truncates, it doesn't round. Right, so now I might want to save this, right? We have now instantiated our trader agents. Oof, that was a long one. But thanks for joining us, and that concludes session 7, where we initialize our trader agents. See you for the next lesson.